Hello everyone, my name is Sriram, and last week we discussed some filters and how they are operating and different things. And these are the filters which we discussed last week. And today also we will be doing the same thing, but the change is last week we taken the input in the form of array, but now we are taking input instantly using a sensor. So we are using a sensor to take the readings, and this is the code which we are using today. And our main operations are: first thing, choose a filter to smooth out high frequency noises present in the signal. So we will be using MA filter. And as in when we go to this code, and here we are mentioning a array named sensor value, and we are taking 500 inputs, and we are defining an array, so we can add the inputs to this. And initially we are taking length of MA filter as 4. And when we go here, uh, this is the code to take the inputs. So we will be connecting our sensor in seventh port of the analog, seventh analog port. So we are taking readings into this array, sensor value array, and we will be taking a delay of 10, so that we can have a gap between two different set of values. And by this loop, we are taking the we are taking the values, and we are storing them in a sensor value, and number of values will be 500. And here I am defining some arrays name x, y, w, p, q, so we can use them in different operations. And the first one, in MA filter, since we had taken the loop L, and we are doing the same thing as last week. So by this is the function for MA filter. And and we are storing the new values in x, and name x array. So we will be printing our values here. So these are all the remaining values. So I'm putting this in comment, so we can clearly observe that. So let's quickly run this, upload this code. Just wait a minute. Yeah, now it's uploading. Now let's open the serial plotter. So the first one, the blue one, is our input. So let's give it a time, so it will be clear visible. So you can see the blue one is the is the signals which you are giving instantly, and the red one is the MA output from a MA filter. We are seeing this MA filter as magnified because some comments here, because we are giving an extra base, as we can see here. Yeah. So we can clearly see the output is more smoother than the input value. And so that's the MA filter. And next one is, in the next question, in the next one, we were asked to emphasize the slope, so we have to use derivative filters. And here we are using two derivative filters. One is first order and another is second order. And I'm storing them in y and w respectively. Y is first order and w is second order. Here y of I is input at that instance minus input of the previous value, and W is input minus input of previous second previous value. So we can quickly see that. So let's see, let's upload it again. So we can see the blue one is, yeah, the blue one is the input, and red one is the first order differential, and green one is second order differential. So we can see the red one, we can see at this point, uh, we can see the function is depend we can see this is the first order differential red one, and say green one is second order differential. And the third question is to design MA filter with with the length of the filter is floor of 0.8 into n. So here n is the number of the signals we are taking, and as we can see the n here, yes, the n here is 500. So 0.8 into 500 is 400. So let's take ls 400, and we can observe this output of the filter. So I'm putting this differential outputs in comments. Yeah. Now we can observe the output of MA filter with length 400. I'm uploading it. I'm opening serial plotter. Let's give it a minute so it will be stable. Might be just wait a minute so we can check what's the error. So here we forgot to different divide with L, so that's why the output is so much magnified while compared to input. Yeah. So I divided with L, so now we can clearly observe it. Yeah, now we can see the blue one is the input and the red one is the output. So we can clearly see here the output is so much smoother than the input one. So the main difference between first case and third case is this only length of the value. So when compared to the first case, this was so much smooth. So our fourth task was to this is our fourth task, and it was find the output of signal processing system which perform derivative filter and then perform MA filter. So in this for this one, we are so before doing derivative filter, we are initially processing the signal from MA filter, and we are using the output of the MA filter and then processing it through differential filter. So we can see P is the first order differential and Q is the second order differential. And here I am taking input as input is X, so it was initially processed to MA filter. So I'm quickly compiling all the codes at once so we can observe the difference between everything. So while uploading, we can observe two serial plotter. Okay, just give it a minute. So we have to change some code here. Yeah, upload it again. And initially I have taken the photo screenshot of the output. So the first one is the first one is the input, and the second one is MA filter. And here these two are the outputs from differential filter, and these two are the outputs from MA filter and then processed to differential filter. So we can observe it here. The function is much smoother here than when compared to the blue one, and we can see at this point the slope is very high. So the output of the output of the differential filter is high. uh, similarly similarly for the slope at this point is high, so the peak was here. So we can clearly observe the difference between each filters. So that's how we can process these signals. Let's try to see if we can get in live. Yeah, we can see it here. The the red one is the blue one is the input, and the red one is the MA filter. So we can see the red one is much smoother than the blue one. And this input is very clumsy because I am taking the input while I am speaking, so output will be very fluctuating. So let's pause it here so we can observe it. So see the red one is smoother than the blue one, so it is output of from MA filter. And these are the outputs from first order differential, and these are the outputs from first order differential after MA filter. So that's it for this week. Thank you.